Hello and welcome back to today's digital event called CMM, Connecting Mobile Machines. My name is Silke Gartmann. I'm your host today for the next 90 minutes, and I have three very interesting guests with me. And the first one is named Carsten Eckardt. Carsten Eckardt is Head of Digital Manufacturing and Head of Digital Business Solutions from TÜV Rheinland AG. This is a very exciting speech he's going to give us. He will have pretty much 30 minutes for you, and you are able, as the audience, behind your mobile phones or behind your laptops, to actually submit us live questions via talk. So if you want to be part of the entire team and part of the entire discussion today, use it, and use it very often so you can actually have a very fluent conversation with every single speaker today. As I said before, I'm your moderator today for the next 90 minutes, and you'll see me later again. And let's get the first start with Carsten Eckardt. Carsten, can you actually hear, and maybe most of all, more important today and these days, see me?
Yes, of course. I can see and I can hear you.
Wonderful. So you're up and healthy and everything's fine at TÜV Rheinland, as I can see.
Yes, of course. We are here in Cologne and everything is fine. I really appreciate to get the chance to talk to you today and to the audience.
Wonderful. As I know, your topic is from a single component to a trustful solution, which sounds to me pretty fitting since, and I will go back to the audience, we're in the session Connectivity Solutions from Components to System Solutions. And Carsten, as I know, after working in industrial plant planning and programming, training and further educations, as well as product developments, you've been a consultant in the field of manufacturing operations management for 10 years now, which is a pretty long time, right?
Yes, of course. Yes, of course. It's a really pretty long time.
And now you're dedicated to the topic of digitization and production, and you also advise companies in the area of product strategy with regards to future scenarios of Industry 4.0.
Yes, of course. And I guess this will be also a little bit a part of my presentation today, that we move through the product life cycle of a smart device or smart component, which is part of a smart solution. Yeah.
Okay, then I would say the stage is almost, but only almost yours, because I would like to announce your topic. Building blocks for trustful IIoT solutions, smart systems and mobility. Did I get that right?
Yes, you get it.
Okay, then I would say get a kickstart. You're number one in the next 90 minutes, and the next almost 30 minutes are entirely yours. Go ahead.
So thank you. As announced, I want to talk today about from a single component to a trustful solution. And I'm here in TÜV Rheinland since middle of last year as head of digital manufacturing. And in the beginning of this year, I also took over the Department of Digital Business Solutions, where we are developing digital solutions for internal, but also for external customers in TÜV Rheinland. So what we want to talk about today is from a single component to a trustful solution. Yes, of course. And if you think about smart devices and you connect all these components and to one system, and you exchange data. So you have to take into account various aspects of operational safety, but also about compliance, I would say. So if you are collecting data, maybe there are some personal data if you want to make analytics of or analysis of it. So you need to take this in account. And yes, I want to show you today what we are working on, and maybe this could be fitting building blocks for your trustful IIoT solution or smart system, or maybe also for mobility solutions. So let's start with a short overview. TÜV Rheinland Consulting, where I belong to, is a part of the TÜV Rheinland Group. And TÜV Rheinland Group is a worldwide acting company with a worldwide footprint and an revenue about 20 billions and also 20,000 employees roundabout. So we, as a digital business solutions, we develop digital services, and to explain this a little bit more in detail, it's what you can see on the bottom is that we have cloud service and application management, where we have a team, they provide platforms. So all the services we are developing are platform-based services. In the middle, you see three pillars. Let's start from the left. It's in the area of R&D, research and development of smart devices. So we call it ASQ, Automated Service Quality. We can provide, or with this service, we have an environment developed and a platform for automated testing. I will come back to this later and explain it a little bit more in detail. So it's about developing smart devices, or in terms of Industry 4.0, cyber physical systems, which is always a mechanical or electromechanical part, which is in addition a piece of software like a firmware. In the middle of, or in the pillar in the middle is if you are connecting all these smart devices together, we are building and operate IoT solutions or industrial IoT solutions. We are using sensors and edge devices to monitor and to condition monitoring for assets or our plant devices. And this is also with the connectivity to a back end where the data are processed and analyzed and also bring an added value to our customer. And the last pillar on the right side is the trusted data service. As I was mentioning before, you have some compliance topics if you are using personal data, if you have maybe you have vehicles or you have machines, they are controlled by workers or drivers. So you have data you need. If you want to work with this and you want to make some analysis, it's maybe necessary to anonymize them. Okay, this is what I was talking about the first. So a little bit more in detail, automated service quality, what we are doing there. It's really smart testing for smart devices, and we are fully automated interoperability tests to test complex smart ecosystems or IoT systems from end to end. What this means? It's for the first step, if you are developing firmware and maybe you have a weekly build, you can use our platform to test your firmware overnight in automated test cases, how this works with the mechanical or electromechanical part together. And in the next stage, before you release your firmware as a release candidate, you can test it also completely automated in the full ecosystem of your product portfolio or with other products or with other firmware releases together. This is what we, and the result is of what you get from it. It's really you short your innovation cycles, you can shorten your time to market, you can increase your product quality, and even if you have parts of your or devices of your product portfolio what is delivered by vendors, so you can have improve your vendor management and you can reduce vendor lock-in times. Yeah, and the optimization of support and development processes. Okay. For this is what we have, or how we have realized it. It's based on a reference architecture, what you can see here. It starts on the bottom with the system under test, where we have the system with sensors and actuators and connected via different network protocols like Zigbee, Bluetooth, Wi-Fi. We have also got mobile LAN, and this is how we control and also observe the system. And on top of it, we have the automation layer, which is really controlling or the control systems. They can control some. I got a message to control the system as in the test cases defined. So during this execution of test cases, we are logging data and tracing, and then we are processing this data in a back end in a time series data space where we store this data, and on top of it we can have analytics, reports, we use machine learning to get findings, and we can visualization for our customers. So this is the part when I was telling that we are testing a smart device ecosystem. So this is on the left-hand side, you can see the observability. There we are, the system under test, really sniffing all communication channels, and we can decrypt the communication protocol, and we can find how they are pairing, how they are communicating, if they are working together and exchanging data. In the middle, you can see a little bit part of our platform where we have defined device classes, so that test cases or the device classes are responsible to know all the parameters and properties of a device which is used in a test case. So you define device classes using in a test case, and the test case is automating the test environment. And during execution of the test, we collect all this data and bring it in a format to analyze it. And this is what you can see on the right-hand side, that you can gain insights, quick and easy access to our test protocols. We have already dashboards, including where you can easily make reports and analysis of the test. So this is a short view in our IoT lab in Cologne, where we are really building up such test environments, and you see on the bottom that our colleagues, they are working on this test cases or on this analysis, and on the right hand side in the dark, this is mostly that we are running such test cases in the night. So. If we are coming to connect smart devices together to a smart system, this is the part that we can see here. It's IoT or industrial IoT solutions, which means that we are connecting assets like machines or some our environment of a building or of a production plant with sensors, and we're collecting data not only from the sensors, also from maybe PLCs in a factory way or in an industrial way. We can also collect data from control systems in different like cars or vehicles. And yes, and we are bringing them together on an edge device. We make a processing of the data and compiling or compressing it and sending it to a back end where we work with this data in a way to bring it in time series, to make some analysis. We are working with machine learning and anomaly detection on that. So this is what we are thinking about to get from this data, not only from one machine, from a lot of machines, to create or to build up a control center for our customers where they can have a real-time view on their assets, and also having the possibility to get insights in maybe root cause analysis if something happened, or if they can see it in prediction where they maybe run into a bottleneck or another problem. So also therefore we have designed a reference architecture. You can see on the bottom again the sensors, but on the there's also an edge device. So from sensor to edge devices, sometimes we're using cables, sometimes we're using different local communication, like Wi-Fi communication, but from the edge device into the backend, it's now mostly that we are using LTE to send data in the backend and to processing this data and storage this data, and by doing anomaly detection or analytics, we also, if we have some findings, we can send a message or push a message to the responsible person at the customer side. And of course, we have a visualization, so like a dashboard that you always see the actual condition of your assets. And this also we can combine it with some our GIS data or something that you have a view about maybe all your production locations, and you can see and you can zoom in if there's a problem. What is also a very important part of of this architecture is on the middle to the device configuration part. It's that we are from the back end can reconfigure or make some updates on the edge device and also on some smart sensors or smart devices in the machine. Okay, this is a little bit on how this can look like. On the left upper part, you can see some pictures like we have a non-inverse solution for condition monitoring of this is an elevator. So we have some sensors and we have sensor kits where they collect the data, bring together the data from some sensors, and we have 3 kits with 2 or 3 sensors on it, and then they send the data to an edge device via Wi-Fi, and the edge device is already pre-processing the data, compressing it and sending it to the back end. And on the back end, you have dashboards, as you can see on the right-hand side, where you can see the actual and the condition of the asset, and also you can make some analysis or reporting of it. And on the bottom, these 3 smartphone screenshots, it's a little bit about the messaging, what I was telling, that in case of anomaly detection or something, other events, we can send messages to service personnel or supervisors or whatever. Okay, this is also what we see in the past, on the younger past, is that there are some production where also the environment conditions, like the humidity in the production hall, or like the temperature, or maybe something else, it's also relevant for the product quality. So what you can see here is that we was also building and monitoring for buildings, like that we can energy consumption, water consumption, all this monitoring, and also the temperature, room temperature. Maybe also we can observe or monitor the air condition and all that. And this, if you bring it together with your product quality and also with your machine conditions, so you can gain more insights in your production, and you can maybe understand more why you run in some quality issues. Okay, the third part was the trusted data service. And this is a little bit about the data protection, compliant processing of data. So in this case, what we are seeing here, it's about monitoring cars of a fleet management. So the fleet manager wants to make some or get some insights in the car and the condition of the cars, which is in his fleet, but the cars are driven by drivers, and so parts of the data coming from the car are personal data. So, and you can't use it as you maybe collected. So this is why we have developed this trusted data service, which is like a data gateway between the car data and the fleet manager or the insurance or whatever will want to use this data, so that we can make sure or secure that personal data will be anonymized. So, and this is a thing we can see here more in detail. We have the data supplier. This can be the OEM, or we have this with this ODBC connector from the data from the car. That data will be sent, and it's not really clear if this is technical data or personal data or person-related data. So this our service. If this data are coming in, check if there's an opt-in by the affected person. So if there's no opt-in, it's refused the data to transfer to the service on the right-hand side. And if there's an opt-in, then it will be anonymized and transferred to the data consumers on the right-hand side, which can be a dashboard for the fleet manager or our service provider. They want to have or they want to provide additional services based on this data. And what we can see also on the right side, on the bottom, is we have an administrator, and the administrator can also give some rights on this service. So we have an rule management also that not everybody or not each service can or not each service can be used by everybody. So there's also rule management included. We are talking here about personal or personal-related data, but also another use case could be that data you are collecting from your production, and you have maybe a hybrid cloud infrastructure, which means you have data you can only use internally. So you will have it on your cloud infrastructure on premise, but you also have a part in the public cloud, and you make to ensure that no data with the internal classification can be transferred to a public cloud. So this is also a possibility where you can use this service for. Okay, the other thing is that we have in Cologne here. We saw some pictures in the beginning. This IoT lab, and this is what we are using for prototyping and POC. So it's a little bit restricted at the moment. But if this is after COVID-19, you are invited to come here to Cologne to see what we are working on and the way we are doing it, and also maybe we can start something together to develop a digital solution for your challenge or whatever. So this is a little bit about also, we have also an IoT training center where we are working on, or our colleagues also offers training for employees and workers. And the other thing is that I was telling about in the beginning about the platform-based services, and on the left-hand side you can see that we have different stages where we are working on platforms. It's like a conceptual level on the top, then we bring it in our IoT lab so that we have an own infrastructure there where we can prototyping and also have an POC for that, and then we are going and transforming this from a lab environment to a production environment. And you can see under the IoT lab that we have installations in our corporate IT environment, but also we transfer such solutions then or services on premise to a customer. So that you can see it on the right hand side, it's a little bit what we are using conceptual or the target platform architecture, what we use, and the target toolbox we want to use. That's it. I guess 30 minutes are over. I thank you for your attention, and if there are any questions, I would like to answer it. Thank you.
All right, thank you, Carsten. Now I can see you again. Thanks for joining CMM Connected Mobile Machines and Mobility in your session, and thanks for the very interesting presentation. As far as I can see, I have no questions from the audience, but as you might suspect, I have a question, because I listened quite carefully, and one thing is, at least to me as a moderator, not 100% clear. What is precisely the role of TÜV Rheinland in the area of connected mobile machines in mobility in general?
In general, yes, yeah. Of course. What I want to try to say or to show here is that we are partners for the whole life cycle of a smart device, from the development to the market access, to the building a solution and operating it, until to data handling in a compliant way.
Okay, that's understandable.
Yes, and as we are TÜV, we are independent from technology and any products. Yeah.
Okay, so a big thank you from me, and I guess a big thank you from the virtual audience as well. You might not hear the applause, but keep it at heart. I think it's there.
Thank you.
Have a good day, stay safe and stay healthy, and thanks for joining us today.
Thank you. You too. Bye-bye.
And for the audience, for the virtual guests out there, this was Carsten Eckardt from TÜV Rheinland. And my next guest is Florian Bonanati. He's already in the line, but we need a few more seconds to set it all up properly. So maybe you grab a coffee out there and join us in a jiffy. We'll be back. See ya. As promised, we're back at CMM's conference, Connected Mobile Machines and Mobility. And as I said before, my next guest is Florian Bonanati from R3. And now I have to look it up because it's really complicated. R3 says reliable real-time radio communications. This makes me quite curious, but before we speak with Florian, I'd like to give you a short introduction on who he is. He has 10 years of experience in turnaround management with Roland Berger and the Boston Consulting Group, mostly on telecommunications and industrial goods. And he has 5 years of practical knowledge building up R3 from a MAC protocol technology to provider of industrial grade wireless products. Sounds quite theoretical to me, but since I have him online, I can ask him directly. Florian, what does all that mean? You're the managing director of R3. Tell me a little bit of your background, please.
Yeah, thank you very much for the kind introduction. Well, my background is that I'm trained as a business guy, so I'm not an engineer, but I'm heading with my colleagues this company for 5 years, and becoming, let's say, from a purely technological idea and first implementations now to products which have reached industry-grade wireless technology, and with that we basically support these use cases to make machines mobile, for example, and we can control the wireless links in such ways that the control and safety aspects of today's cable-based technologies can be maintained on a wireless link.
Okay, this is something I understand. And your topic now, as far as I hope I got it right, is on EchoRing with massive cooperation as a simple, effective, and cost-saving solution. This sounds not economically perfectly self-centered, and I really don't understand it from an industrial point of view. So maybe you can give us the intro on how does all this fit together with connected mobile machines and mobility, both from the industrial sector and the economic sector. I'd say the next 20 to 25 minutes are yours. Feel free. The audience is yours too. Hit the stage.
Thank you very much. And I hope I can give you a much better picture now in a couple of slides and why this is a great solution to connect your machines with an easy product fit. Let me start here with the presentation. So the agenda is fourfold. So first of all, I want to introduce a little bit the challenges of industrial wireless solutions, technology-wise and commercial-wise. Massive cooperation is the mean we are leveraging in our products. It's a software-based technology which achieves this highly resilient wireless links, which you need for these types of applications. I show you also why it's great and it's cost-effective, because it's based on commercial off-the-shelf hardware, meaning standard hardware, nothing special developed, just software-based optimization. And in the end, I also show you a short video which gives you a good view on how easy it is to use our products with your machines today. Let me start with the challenge of industrial-grade wireless solutions. There's a lot of talk right now about 5G and these types of wireless areas in order to support machines and not only, let's say, what we use in our daily lives. And the key aspects here are, when you look at the requirements of such applications, are latency and reliability. Reliability measured in packet loss for the application at certain deadlines. So when you have machines today, you all know you need to be in your control cycles of the PLCs, for example, and you need to be able to serve the safety protocols as well at the same time in order that the machines do not stop. And with, let's say, consumer-oriented requirements, they are on the lower bound here. This is not what machines need in terms of communication availability. And this is exactly what we have built up in our products to serve these types of communication behaviors. So there is a lot of problems within that, because wireless links are not easy to manage, and especially when it comes to an overall solution, there are a lot of costs involved on later stages, which basically are against your business case if you do not comply with them. So first, you need to have a wireless technology, which is able to be, from a technology perspective, to serve such complex communication behaviors. There are some problems here involved on the technology side and the commercial side, so flexibility, for example, and technical issues, which introduce a lot of cost in the wireless systems. The second is you need to be able to integrate it in an easy way in today's existing controlled architectures. And there you have two aspects. So you have a technological ecosystem problem. Can you work with all the different industrial protocols around here? And on the other hand, there's a lot of cost involved in time to market. And in the end, if you build up such products and applications, you need to be able to work with them, because wireless is more like a sensitive field and it's new. So you need to be able to diagnose and to reduce basically revenue loss because your systems are unavailable. Coming from these, well, requirements on the technological side and commercial side, in order to have an effective solution, how can you come to such products, and how can you use them today? So massive corporation, which is part of the next chapter here, is a highly effective mean, and I tell you what's different here to existing systems and why it's highly effective as well. First, if you look at the wireless channel itself, you all know that, also from your personal experience probably, that your link quality changes depending on what you're doing and where you are. And the reason for that is that you have channel selectivity. So basically the link quality fluctuates over time in frequency and in signal quality. And this makes it really hard to come up with an industry grade wireless solution, because your machines need all the time a good wireless link if you want to get mobile. The second is that you are in a broadcast medium. This means you need to deal with other systems around you. They may be, are so close that you cannot transmit at the same time because packets are colliding. So this is another challenge, which is not easy to tackle. And the last thing is, in order to come up with similar behavior as on your cables, you face spectrum limitations. So as you all know, you cannot just access any frequency. So typically you're working with 5 gigahertz or 2.4 gigahertz, and the spectrum is scarce. This means also here there's another limitation which makes such systems and products quite challenging to come up with. So in order to come up with a solution, you need to have two things in place. So this is reliability, and you need to have the reliability at a low cost. And there are different ways to achieve that from a system architecture. And some are here mentioned. So frequency redundancy, you can send packets in the same frequency at the same time. But of course, this takes off some channels you could use for other things. And multi-antenna systems and corporations. This is what we are going for. And latency, that's the other aspect. So in order to come up with a low latency system, you need to be able to support, of course, a different scale of systems in the same manner. So in the end, you face again the scarcity of the spectrum, that you don't have enough channels. On the other hand, you need to be very careful about your hardware setup, because you should not lose at any point in time from your actor to sensor and to compute any latency. Because if you do that, then whatever you do on the wireless link, it's basically does not help anymore. Because if you lose, for example, a millisecond on your controller, where not a real-time operating system runs, then whatever you do on the wireless link to optimize that does not work. So in the end, you need to have a comprehensive view here on the hardware setup and the software on it. I want to focus a little bit on the reliability in the next couple of slides. So massive corporation as an introduction basically helps here, and it's said and it's shown on the right side. If there's a packet lost from one station to another, from one mobile machine to another mobile machine, the packet is recreated on another mobile machine in order to send it on a different path. And not using the same path, this helps strongly to increase the resilience of that system. And as you all know, cooperation is always a good feature. The question is, how can you make it up and set it up? And in the next slide, I want to show you in comparison to Wi-Fi systems, access point oriented systems, what it really means, especially if you're in dynamic setups. So typically you have a first attempt, and if the first attempt is not successful in conveying the packet to your destination, the system typically repeats that packet. And when you look into a standard access point oriented system like a Wi-Fi solution, where the communication always goes directly from the sender to the receiver, you only have time redundancy. So you send the packet, then you resend the packet, and if the link was bad in the first place, it's probably again bad in the second step. When you look into an ad hoc cooperative solution, which EchoRing is, we leverage all communication nodes around you. So if that packet does not go through on the first transaction, then we resend the packet through other nodes, other machines in that network, in that area. And that makes it very resilient if, for example, something is in between the first pair of communication nodes. And if you are in a mobile setup, you never can anticipate everything before. So you need to have a very dynamic system in order to make the wireless networks work in a way machines expected. I want to show you a comparison here from between systems which repeat the packet on the same link, like a Wi-Fi or even a 5G system, and compared to a cooperative working system. And what you can see here is that these are packet error rates. And the lower the bar, the lower is the packet error rate at a certain set target latency of a control loop, for example. You can read the assumption in the notes below. So the main thing is, if you look at access point oriented architecture and massive cooperation architecture, you basically compare the first two bars with the last two bars. And what you can see that cooperative features reduce the packet error rate at certain latencies tremendously. This is only one part of the picture, because this is just a summary of that trial. If you look at it in over time, it gets even more interesting, because you see here there are a lot of periods, for example, where in that area, I'm not sure if you can see now you can see it, where nothing is a problem. So the wireless networks work perfectly. But you see in the other areas where the density of these points is there, that at certain point in time, certain setups, maybe where your machines are operating, the wireless connectivity gets into trouble. And if you do not have cooperative features here, you lose packets. And if you're leveraging relaying adaptive corporate massive features in your system, this reduces the packet error rate where you are in trouble. Now I'm jumping to the next chapter, which is about implementation on today's commercial off-the-shelf hardware, which makes it a very interesting and cheap, in this sense, way of introducing such wireless links without complex infrastructure around you. We have come up with a software stack which integrates basically from the interface through the whole stack, through the different parts of the hardware, and optimizes the complete path. Here we focus, of course, on the resilience of the wireless link, as I said at the beginning. It's also the application integration for different interfaces and with different protocols which are around in the industry, because every protocol, every interface has its specifics. And if you do not take that into account, you will not have a working solution in the end. And the last thing is we introduce as well network management tools, which helps you to set up such networks, diagnose such networks, maintain and operate such networks. And just that in a little bit more detailed way. So the first thing is, again, we leverage different parts in the network to make the wireless link resilient, because if that breaks down, your machine potentially goes into a safety stop because the availability of the connection is not there anymore. The second thing is we offer different ways to integrate that on a module side, but also on a complete hardware package, which you see on the right side. So it's a kind of a transparent Ethernet bridge, very easy to set up, and we support different industrial protocols. And there's more to say to that, of course, in detail. But you can run it with different ecosystems. And the last thing is, as I said, there are tools around which help you to maintain such networks and to operate these machines then later on. So key features are here. The first thing is, for example, fast boot up time. So especially in mobile setups, you need to get into operation mode quite fast when you switch it on. And this is foreseen in our hardware and software architectures. The second thing is we allow at the same time different traffics, and we, for example, priority traffic and non-priority traffic. So for example, for diagnosis, you don't need high resilience, but for example, for safety or really control-oriented traffic, you need to stick into the cycle times. And this is optimized with different queues in our system. We also offer seamless roaming, meaning especially on a mobile setup, you need to be able to cover bigger areas without that your connectivity is lost. And I'm not talking about, let's say, what you experience with Wi-Fi. I talk about that the application does not realize that the network has changed in the set cycle times. And of course, there are security features available which make it secure in a way that nobody else can easily introduce or go into the system and manipulate it. And to complete this picture, we offer our stacks on complete products, like the Ethernet bridge, which is there and can be used in industrial settings. So IP65 hardware with M.12 connectors. We offer system and modules and have partner modules available to make it more integratable into your systems. We also work with reference design and purely software integration if that's needed, and help you to integrate these stacks. So in the end, with this system, with this cooperative approach, we make it, first of all, resilient on the wireless link on the technological side. But on the other hand, we work on standard Wi-Fi's. So there is no special receiver architecture needed. So low cost is guaranteed. As it, for example, the Ethernet bridge is laid out as a transparent interface. It's very easy to work with different components, different interfaces, and from different suppliers. And we help you with our software and different options here to make it easy and fast in the development process. And the last thing is that, of course, our tools help you to prevent downtimes and to fast diagnose if something goes wrong, so that the availability of the system is still high and does not go down. Well, what are the use cases we support and the product setup? So if you look, for example, at an automotive factory, we come into a lot of areas with our system. So where everything is moving, for example, at geometry tables, slip ring replacement in the body shop, when it comes, let's say, to more like logistic-oriented setups, or later on in robotic tools as well, where cables are in the way, break down, and more mobility is introduced, until intralogistics platforms, until to the assembly lines. control these. As I said at the beginning, I want to give you a concrete picture how easy it is to set up our networks. And here is the video clip. I hope you can see it and can listen to it. And let me start it.
Five steps how easy it is to set up an EchoRing network running to industrial PLCs.
Let's do that.
Perfect. So I'll switch it on and Thomas explains what we have here.
So what we got here is two Siemens S7 1200 devices. So one configured as controller, the other one as device. And between the two of them is running ProfiSafe over Profinet, running an update time of 16 milliseconds.
In order to configure EchoRing properly, we need to understand what traffic pattern is exchanged.
Exactly. And we do that by using a nice feature of that switch we are using, which is the monitoring port. And by connecting an Ethernet cable to that port, we can monitor live all the packets being exchanged between the devices.
So what do we learn here?
Those are three things. First, the size of the Profinet packets, which is 64 bytes. Second, the periodicity of about 16 milliseconds. And third, for the prioritization, the Ethernet type for Profinet.
So now in the third step, we will configure our EchoRing Ethernet bridges.
So we got the three EchoRing Ethernet bridges all connected to a switch, and also connected here is our configuration server, which runs the configuration tool, accessible via its webpage.
Great. So why do we have three Ethernet bridges?
Oh, it's two of them will be connected to the actual Profinet devices, and the third one will act as relayer to make use of our cooperation approach.
To make our wireless connectivity really resilient.
Now we connect to the three stations. First, we assign the MAC addresses of the Profinet devices to the EchoRing stations that they will be assigned to. Second, we adjust the prioritization according to the ether type. Third, we adjust the EchoRing parameters according to the traffic we analyzed before.
Okay, great. Let's deploy this configuration to the Ethernet bridges and start the EchoRing network. With the health monitor, we make sure that the link quality between the Ethernet bridges is optimal, based on their location to each other and the configured transmit power. In addition, we also see if the wireless traffic is as expected. So what do you say, Thomas?
So link quality is great, and EchoRing management traffic runs as expected.
Now let's switch on the Siemens PLCs again.
Not connected, so orange and red LEDs.
Now let's connect our EchoRing Ethernet bridges to the Siemens PLCs. Well,
Up and running again.
up and running again, now via EchoRing. And on the health monitor, we can see that this connection has been established between the two PLCs.
Additionally to the EchoRing management traffic, we now also see the Profinet data being exchanged.
I hope that the connection was good enough to show you the video here. I also hope you get an impression how easy it is to connect our devices to existing PLCs. And that would also be my last slide here, to stop here at the presentation. To summarize, we came up with a software-based technology in order to create a wireless connectivity which is able to work with existing industrial protocols, industrial PLCs. And this is now packaged in a complete device with support tools around in order to set up networks in such an easy way as we showed you. And he would stop now. It's 12:30.
12:30 sharp,
very
I
much.
would say. Thank you, Florian. As I said before, from the title of your presentation, at least to me, having an economic background, this was not self-explaining. However, while listening, I at least got a teeny tiny glimpse. Maybe, hopefully, I couldn't recite, but still, I got a teeny tiny glimpse of what you guys do. It sounded quite interesting to me. However, I wouldn't be able to make any use of it since I'm not in the field. But I guess the professionals joining the session got a very good impression about what you do. And therefore, thank you on behalf of CMM that you were part of this entire session. And let me check if there are any questions via talk. As I can see, there are none, which means your presentation was 100% perfect and nobody has a question. You explained everything you needed to explain. Absolutely wonderful. So thanks from my side on behalf of CMM to you. Is there anything you would like to let us know?
Well, thank you very much for the time. I rushed through the presentation, of course, and it was complex, as you said. But I hope everybody who wants to connect machines and faces problems of the wireless connectivity could see that there is a solution, an easy solution available. So I'm happy to answer questions afterwards. So please just contact me or my colleagues over the webpage. Thank you.
Absolutely. Thank you, Florian. Have a good day. Stay safe and healthy. And I guess the professionals will approach you and talk to you later on. Have a good day.
Thank you. Bye-bye.
And to all you out there who just listened to Florian and his very, very nice way of explaining a very complex situation, get in touch with him, use talk, or just start to approach him directly, whatever you feel works best for you. My next guest has already lined up, and his name is Stefan Miller. But as we need to set up his presentations, you do what you did before. Grab a coffee and stay with us. See you in a couple of minutes. Bye-bye. And we're back, as promised. Connectivity solutions, from components to system solutions. This is this session's topic, from connected mobile machines and mobility. And as I said before the break, my next guest is from Nokia. His name is Stephen Miller. He's head of Automotive Global, and I believe he's with us already. Let's check. Stefan, are you there? Hello.
How are you?
Thanks. How are you?
Not too bad, not too bad.
Not too bad. Everything's safe and healthy with you?
Absolutely, absolutely.
That's the question of all times, right?
Yeah, we're stuck at home, so...
I can see. Okay, but since you have another 30 minutes for you and your presentation, I don't want to cut you short, so therefore let me give you a teeny tiny outlook on what you are about to present the entire audience right now. As I believe it's about scaling 5G factory use cases in automotive, from factory data shower to secure OTA updates. Now, what the heck is this all about? I'm completely clueless.
Now, this is just like, I'm just like trying to look a little bit beyond the manufacturing use cases. meaning the automotive industry is heavily looking on cost reduction and on the other side on new revenue streams and using the technology. And the data show is one out of many use cases which can be leveraged, but that's one of the use cases which can be just like leveraged, I would say, as of today, with a positive revenue or a business impact.
Okay. I assume you have a presentation already at hand. I would like to address the virtual audience again by letting them know, please send us your questions via talk so you can get in direct contact with Stefan Miller. Don't hesitate to put anything online you ever wanted to ask. And I would say, Stefan, it's your turn now. Start your presentation. Have fun.
Thank you very much. Hello, everyone. My name is Stefan Miller. I'm calling from southwest of Germany. And I would like to just tell you a little bit about use cases which can be leveraged. But before I jump into the use cases, I would like to start with my agenda. I'm going to start with the trends because I think that's pretty important to have the baseline. Then I would like to focus on the use case itself and looking a little bit beyond the use case and what is relevant to make that happen. Now, having a first look on the trends in the automotive industry, we have a bunch of trends which are influencing the automotive industry and the strategy of the OEMs. But one of the important influencing trends is the technology change where 5G comes into place. And where we as Nokia have, to my understanding, also the right technology, not only from a CSP point of view, also from a private wireless perspective. And I think these things are coming now a little bit together. Now, having a look on the strategy focus areas, we see electrified, autonomous, shared, connected, and updated. And I would like to focus today especially on the connected and updated trends or strategic areas where we see just like a lot of change in the near future. And this all goes along with cost reduction in the automotive industry. And I think the 5G data shower use case is one of the use cases which addresses just like on one hand the strategic areas in terms of connected and updated, and on the other hand on the cost reduction targets. Now, why choosing this use case, or why focusing on data shower? There are a bunch of other use cases in a factory which could be leveraged, to my understanding. We have the HV use cases where, for example, the positioning in the 5G system is of relevance. This can be leveraged also to the facility management, where we see, for example, the robots who are cleaning the factory. We have got camera use case and all the other things, but the business impact, to my understanding, is the biggest with the data shower. Now, why exactly focusing on data shower first? From a technology point of view, we have just like everything in place. So meaning, to my understanding, we don't have a chicken egg problem. We see a lot of, just like from a network perspective, we are there, especially in Germany, as private wireless is now available from a spectrum perspective, also from a connectivity perspective. On the other hand, when it comes to a chicken egg problem, we need the equipment also equipped with 5G modems. And when we have a look at the car, we see that the car manufacturers are equipping their cars with 5G modems, just like starting as of next year. So there we have just like everything in place what we need for that use case. From a technology point of view, from a 5G technology point of view, we have the release 15 already live. This release is responsible or covers the upload and the download topic. So from a technology point of view, hardware perspective, everything is in place. And from a 5G technology perspective, the necessary release is also live and can be used. The other releases are just like important in the near future, but this is just like a release where you can start off to implement that use case as of today. Now, what does it mean, data shower itself? It's just like a project name within Nokia. Data shower means that we are filling the car with software over the air. This is already done. We are just like external devices which are connected via Wi-Fi, and these devices have to be plugged into the car, mainly the OBD interface. And this, just like to our understanding, can be optimized with the 5G technology, meaning once you have private wireless installed in your factory, you can just like interact with the car with the 5G modem in the car directly, so you have less cabling, less human interaction. The download is going faster, and in the end, just like there's time saving, just like on a human factor, and there's time saving in terms of speed of download as well. So that's just like the starting point. There's a big value within the production process for that use case, but having a look beyond that, and we see just like over the air updates already in other areas of car manufacturers. Just imagine you're working in an R&D department and you have to update the car. In practice, sometimes two persons with your colleagues, you're going down to the car, you're doing the update, which costs you half an hour or an hour. You're sitting in the car and you're non-productive. With a private wireless solution on a factory grounds or on a campus, actually, you can do the updates also over the air, meaning you can just like sit in your office, you can send the download to the car in a secure environment, and I think that's pretty important. You can do updates over the air in a public network, but especially when it comes to, and there's the point where it starts to become of importance for private wireless, especially when it comes to updating electronic control units, which are critical, meaning just like steering wheel, brakes, airbags, and all this kind of stuff. There, it's pretty important to be secure in the update and to avoid any damage from outside. And especially the European, or most of the global companies are trying to separate that. They're doing over the updates already in the public network, which is good for non-critical ECUs, but when it comes to the critical ECUs, there's always a risk, and private wireless can minimize that risk to a very high extent. So R&D is one of the use cases where you can leverage that pretty easy, just like place another radio outside the factory, and normally you're then able to cover the R&D space as well. Production, I've already mentioned. Logistic is the next point. Also, an outside radio can just like help to scale here, meaning once a car is leaving the production line, it goes to a buffer place, and in case you have to update here, it's very seldom, but it can happen. Then you could also use the private wireless technology for secure updates. And last but not least, the retail. Here we see also updates on a regular base, and this is a use case I would like to outline a little bit more. Meaning within just like on a campus, it's pretty easy to scale the solution. When you start introducing private wireless in the production, you only have to just like put outside antennas to cover R&D or the logistic place. When it comes to the retail, we from Nokia, we have just like we can scale down our solution as well. So you have just like a small private wireless solution which can be installed on a retail place as well. The retailer is already connected via VPN to the headquarters, so the data transfer from the headquarters to the retailer is pretty safe. And in terms of an update, our understanding is we could do that in a private wireless environment on a retail place as well. What does it mean in practice? A retailer would need to install a private wireless solution, which is really limited to a small core and a small radio, and then they could do the update. And having a look on the business benefits here, we see updates just like on a more or less regular basis. Dieselgate was one of the biggest, which most of us have experienced. you get a letter from the headquarters saying you have to update your software, otherwise you're kind of illegal. And this was one of the massive updates I think we experienced in the last couple of years. In this case, the end user had to drive to the retailer, or had to call the retailer, has to set an appointment. Then you have to go there, drop the car, take a rental car, in the evening you have to drive back. Imagine you can just like drive to a retailer within his private wireless area, drink a coffee at the retailer, and once the coffee is done, you can drive off and you have got the update in the car. That's just like a little bit of the vision or the idea of scaling the use cases. From a technology point of view, you have to make sure that these updates are possible within the car. So there is something to do from a software perspective in the car, for sure. But when you enable such a solution in the production, you can easily just like scale that to other departments on the headquarter campus, but also outside your campus, for example, in the retail space. Now, what is the benefits? And where comes the return on investment? We see on just like on the campus of a headquarter, when we have a look at R&D, production and intralogistic, reduction of human interaction. So that's just like a direct impact. And we believe that with this technology or this solution also helps to process the production and the cars a little bit faster in the production and also in the logistics space. But having a look a little bit beyond, especially on the retail side, a massive impact, and I think that's a pretty simple calculation, is the reduction of recall costs. It's simple. It's just like when we just like use public information, but I think that goes along with the reality pretty well. An hour within a retailer costs roughly 100 euros, and imagine that an update will just like block or will need just like an hour or two in a retail space, and that multiplied by the cars of a recall, there you have just like pretty easy the budget for an investment set, or the baseline where you shouldn't just like go above for an investment. But there we're I think pretty close. The other thing is higher workshop utilization, so the retailer is not getting blocked by the updates, and he can process basically the cars a bit faster, even when it's a regular just like updates. They don't need to leave the car in the garage. They can just like do that outside, and they can use the time in the garage for other things and generate a higher margin with that. And last but not least, and I think that's one of the most important things, that's the end customer, meaning the brand experience will then completely different in this case, because especially when it's a recall, there it's a complete change on the brand experience. And in total, we don't know that yet, but I expect that we will see just like also updates where the user needs to just like go to the garage a little bit more often, and there just like the brand experience will completely change. And now having a look a little bit on the ecosystem who is doing that, and our belief is, and that goes along with Industry 4.0, I think in many spaces, it's not a single player of one supplier anymore. There's a need that we need to collaborate in an ecosystem. For that solution specifically, we need a cloud provider. We need consulting who are enable the process. We need service integrator who are doing the integration, locally integrated to just like to do the installation. We will need telco industry, and we will also need the tier ones who enable their ECUs to do such kind of use cases. And having a look a little bit beyond, and that's maybe for some of the audience a little bit futuristic, but we experienced that already from as we had the technology change from 3G 3G to 4G, where we've seen just like new things coming up where we never thought they're gonna be there. And I'm pretty sure that startups will create new ideas once this private wireless system is installed also on a retail level. I've spoken to marketing agencies who are already about to think about what can we do with this new technology from a marketing experience on the retail space. And there are limitations of existing systems, especially when it comes to flexibility and broadband in a retail store. And we also see a really big shift within the automotive industry in the retail towards digitalization, meaning the digital experience within a retailer gonna be completely different in a couple of years' time than it's today. Pretty sure that companies, software companies, will also generate new ideas and new products on them. And last but not least, the OEM internally can also just like generate new ideas, new use cases around the new possibilities with private wireless to generate new experience for their employees or to optimize other processes in total. Now coming to my last slide as a summary. To our understanding, and this was one of the use cases, and there, as I mentioned, there are other use cases as well. Private wireless is now available and it pays off for cost optimization. The value of use cases can be leveraged across business units. I know this is sometimes a bit of a challenge when we see the different silos, but I think it's pretty important here to have a big picture on the use cases so they can be leveraged just like across the car manufacturer. And last but not least, it's important also that we have a look at the ecosystem. It's not a single player of a Nokia itself. We need just like the ecosystem to make that happen. That's, I think, pretty important. And my last picture is that we, from a Nokia perspective, we've implemented that technology already in our factories, and we can, and everyone is invited here. We can showcase already the savings we've done with that technology, and that's a good thing on the automotive industry. I think we can think that a little bit broader. Within Nokia, we have a bunch of products which support that technology. It's not only the hardware we are providing, we also have some software pieces who support that technology, who support that change. And with that, I would like to close my presentation and will be available for some questions.
Thank you, Stefan. Let's see if we have any questions. My screen says there are none, but as you might guess, since I listened very carefully and intently on your presentation, I do have a few questions.
Okay.
My first one would be, how can 5G use cases from the factory be reused within the OEM ecosystem?
How?
How?
That's just like, just think abroad. Once the use cases are just like mentioned with the software update, once it's implemented, the use case in a factory, it then can simply be used, for example, from the R&D colleagues, who can then just like update their R&D cards over the air within the private wireless system. The only thing is you have to just like plug I would simply say plug a additional radio outside of the factory to cover also the R&D space. Mm-hmm. That's just like the thing we are in the discussions we are in. It's mainly focused on manufacturing because we are talking to the people from the production area. But I think it needs to just like put on a broader perspective, meaning when you say everyone is looking for a business case or for a business value with the use case. And I think when you start in the production, and I think that's a good place to start, the people in the production, they need to think a bit broader, and within the automotive industry or within the company, they have to start also to think a little bit cross silos, I would say.
Okay, thank you for that. And my second question is, what are the added values for the OEM, but also for the end customer?
For the car manufacturer, I think that's just like more margin because of the cost reduction. That's just like, I think, the main trigger for the business case. And the additional use or used business value is then for the end customer. And I think brand value or brand experience, customer-centric itself, just like using that as a buzzword, is one of the focus things in the future. It's pretty hard to differentiate a brand, meanwhile, due to different reasons. I think we see just like, especially in the premium sector, the companies, they have to deliver just like always things on top to make the experience with the brand more comfortable. We see Tesla, for example, they're just like from a digitalization point of view, really just like the highest level as of today. But I think there are differences when we compare that with some premium OEMs, especially in Germany. They have a higher expectation on security, for example, and that's, I think, where the difference is coming from.
Yeah, that sounds understanding. My last question before the lunch break. This is explained using the example of the factory data shower entirely. So does the factory data shower cover the entire range of what you just described?
From a use case perspective?
Yeah.
No, there's just like when we have a look on a plant or assembly process, there are a bunch of use cases. Data shower is only one out of many. We have like HEV use cases where I would say this massive data showering is not the focus there. We have to focus on more likely the positioning within the 5G area. We are working with many tier one players also just like on positioning of tooling. That's pretty important within the production line. We've got camera use cases. We will see with release 18 also massive sensors, which can be connected to the 5G system. So there's a bunch of use cases, and it's pretty individual, I would say. When I compare the discussions we have with our clients, we don't have a single use case where everyone is focusing on. Every plant manager has different needs, different problems, or different focus areas where he believes he should start with 5G. In the end, when we have a look on that technology or the use cases in 5 years' time, I think we see a bunch. As of today, it's pretty individual.
Which is understandable, of course. So thanks, Stefan. Until here, I would say, and I believe you're available for the virtual audience for questions afterwards, since right now nobody submitted anything. But from experience, I know that once people had the opportunity to actually digest what you just told them all about, they will get back to you, and pretty much I'm quite certain they will send you questions afterwards. So thanks for joining us.
Thank you very much. And I've seen already coming some stuff via email. So
see, it worked already. The magic did its work itself. So have a good day. Stay safe and healthy. Thanks for joining us.
Thank you.
I'll see you again, hopefully, at the next CMM.
Hopefully personal.
Absolutely. See ya. Take care. Bye-bye.
Bye.
And for you out there with the virtual audience, thanks for joining us for the past 90 minutes. We're going into a direct lunch break right now, which is pretty much for an hour. So we're going to be back at 2 p.m. sharp. And then my colleague Hartwig is right here on stage with you and will guide you through another few sessions. Talk to you soon. Have a good day and enjoy your lunch. Bye-bye.